My name is Mike Bates. I am Intel's Global Energy Director. I apologize, my Spanish is muy poquito español. So I will speak English, and hopefully if you have some questions during my presentation, someone can help me interpret. So I'm here today to talk to you about the transformation that's ongoing in the energy vertical between internet, IT technologies and operational technologies. In my world, energy is both oil and gas and utility. So we're working with all the major oil and gas companies and utility companies across the globe with this challenge of the evolving business model for both oil and gas and utility, and how we can apply technology to help these utility companies manage this evolution. So I think it's, you wouldn't be in this room today, I don't think, that if you didn't feel that there is this convergence today across the economies, but more specifically today speaking about the energy markets. This convergence is coming together in many ways, especially in the utility industry, where here in Mexico, there's been the reforms that have been announced over the last few years, really moving that industry closer to the customer. And I think when you get closer to the customer, there's a lot of need for digitizing some of your work streams. So we'll talk a little bit about that today and some of the examples that I've experienced in working with some of the larger utility companies across the globe. One of the particular areas that we see occurring is this vast amount of data that's being collected across both of these industries. Data that you can imagine in the case of the market reforms here in Mexico, where you now have 3 different entities that approach the value stream, all the way from the consumer side. So you got an entity now that is working with consumers, building owners, residential customers on their own energy usage, and then working with those clients to create new experiences with the grid operator, which is in a different entity, or soon to be a different entity in Mexico, that has its own set of data. And then finally on the generation side, you've got generators that are producing their set of data. So you can imagine the challenge of mashing up these different data streams and then using the data that you're collecting around customer usage data, using the data that's collected on the grid on how the grid is operating, and then of course using that data to help drive more efficiencies around the generation of power and the generation of renewable power that's being on the grid. So we're working today in this area with utilities and markets that are moving in this direction, trying to create those seamless data streams so that all parties can get access to that data and then use it for some of these, to drive some of these new business models. We had some recent meetings here with some of the folks that have been involved in the market reform and have learned a lot about the need to measure and verify loads at the consumer level for measurement verification purposes, and then to settle with those energy users in the new market. So there's some areas where we're working on that and the data side through Intel technology that is deployed on the edge of the grid, Intel technology that's just deployed in a consumer's home, technology that is installed in a building like this. All of these data, access to these data points, backhauled through communications network, then again delivers new sets of data that utility customers and utility clients really have never seen before. So I'll give you one particular case. We're working with one utility in Germany. It's called E.ON. They're one of the largest utilities in the U.S. They have, in the world. They have seen a fantastic growth of consumer-owned renewable energy resources. These are consumers putting rooftop PV, they're putting in battery storage, they're putting in electric vehicle chargers, but before the installation of these new resources, the utility had no transparency, no visibility into those loads. So the effect is, and particularly in this case, when the German government requires for the local utility to take all the renewable energy that is being produced and put it on the grid, but they're not really aware of what those load forecasts look like. So we're putting technology in between the distribution network and the point of generation to be able to provide the utility a very close real-time forecast of those loads that are being produced so that they can then create a grid infrastructure that can incorporate all these new loads. So it's a very interesting, I think, a future scenario that a lot of utilities are facing with the growth of renewable energy and renewable energy resources. Also talk a little bit about Intel's role in securing these new infrastructures. So you can imagine if the new world of IoT in the energy vertical or in the energy space means the installation and deployment of billions of new devices on the infrastructure in the home, in the building, obviously that new streams of information and control allow the utilities and the oil and gas companies to do things that they haven't done before and become much more efficient from their operations and maybe even drive incremental revenue. So there's a real big upside for deploying IoT on the grid. But there is a downside as well that we're trying to address and working with utilities, and that is the additional threat of on the security side. So you can imagine all these new entry points of folks being able to hack into a thermostat or hack into a smart inverter, and then once they're in, depending on where the soft spot is, they then can deploy, and do things that we don't want them to do through these new IoT platforms. So in Intel's case, we are ensuring that our Internet of Things software platforms and our Internet of Things edge devices incorporate Intel security components all the way through. So there's a full critical infrastructure protection that's baked into the solutions before they're ever deployed. So that's one of the interesting areas that you hear more about with Intel and Cisco and how we're working together. I'll also mention another interesting area where we're using IoT technologies to help some of our clients, and I would title this under what we call workforce transformation. So you can imagine in the oil and gas industry, folks are probably aware that the industry's been under some pressures, the prices have been dampened. In a lot of cases, that has meant a lot of oil and gas companies have laid off significant numbers of employees. This is especially true in the U.S. and some of the U.S. markets. However, that doesn't mean that some of the workloads have been reduced. So what they're challenged with is trying to do more with fewer employees. In the utility space, the problem statement is a lot of the folks that have been working in these utilities have been there for years, and they're starting to retire and move out of that space. And there's a lack of young talent that's moving into this space, so there's a gap in knowledge and that we're trying to help these entities solve. And the way we're doing that is by combining IoT technologies with wearables and ruggedized laptops. You can imagine a scenario where you're a line worker and you walk into a substation or a part of the infrastructure or the grid infrastructure and having a wearable IoT gateway device. That gateway device that you're wearing is interacting with the infrastructure that you're interfacing with. So you could actually walk up to a transformer, you could walk up to a piece of machinery that has a sensor that's feeding its information to a gateway that you're actually collecting real time on your IoT wearable gateway. So that device allows you to interface with the infrastructure, and then you're actually experiencing it through the traditional ways, through a ruggedized laptop that you can take into the field with you. But instead of that ruggedized laptop accessing data through the internet in the back office. It's actually accessing data real time on the conditions of some of the assets they're interfacing with. And we've even gone so far as combining that with wearables like a smart helmet or smart glass. So you can actually walk up to the piece of equipment. The IoT gateway that you're wearing is getting real-time data, and it's being fed back to you via some sort of virtual reality technology. And you're actually working on the piece of equipment with someone from the back office instructing you on how to fix a valve, how to fix a piece of equipment. So it's a new way for workforces to be able to interact, and then actually, as we mentioned before, get some of the younger folks that are moving into the industry more up to speed and easier train on some of the things that the folks that have been in the industry for a long time have worked with. The last point I want to mention here on this transforming business, and this is the part that's really exciting to me, is the connected experience. So we mentioned before, and you guys are all very aware of the market reforms that are going on in CFE and the unbundling of the different companies. This market restructuring that's being experienced here is also being experienced in many other markets. Most of Northern Europe, markets in Texas, and some states in the US. The country of Japan is actually going through this deregulation and liberalization of the market as we speak today. Just a quick note, in Japan, just like here, there were incumbent monopoly utilities that had been in place for decades. In Japan, there's actually 10 that make up an interconnected grid for their country. In Mexico, there's one, which is CFE. Today in Japan, where there were 10 entities providing you your choices for electricity, today there's 300. So those 10 incumbent utilities are now being faced with 300 competitors that are trying to take their customers away. And some of these customers, or some of these competitors, are folks that you would never think of getting into the electric delivery business. So these are companies like telecom companies, cable companies, entertainment companies. Even in one case, there's a travel agent in Japan that's selling electricity, which is a pretty crazy thing to think about. But the way they're entering the market is through, and the way they're acquiring customers and competing with the incumbent, and the way the incumbent are actually competing to retain those customers is through something we call the connected experience. So these are technologies that are installed in a customer's home that allows the customer real time to interact with their energy-saving devices, even through their phone. So as a matter of fact, today I was flying in from Austin, which is where I'm located. When I got on the plane, I realized that I hadn't set my thermostat back to away mode. I went to my phone. I went to the application where the thermostat exists. It also exists along with my water heater controller, and I was able to remotely set my thermostat back to away mode, which is it's not earth-shattering technology, but I don't know that CFE is offering something like that today. If they are, I applaud them. But I'm pretty sure that CFE will start offering things like that in the future as a way to retain their customers. So Intel's role in that is around the home gateway products that are installed in their home that connect to all the different devices that you can imagine that would help you save energy. And then presenting that back to the customer, again, through this thing that we call the connected experience. How am I doing on time, Marco? Okay. So this slide is a very high-level view of Intel and our IoT strategy and our IoT technology. If you look on the, well, it doesn't work. If you look on the far left side, this is what we were talking about earlier. So there is a family of devices and quote-unquote things that get installed by oil and gas company or a utility company on the edge of their infrastructure. This could be in a home or a building, and those devices are connected to a gateway device that's on the distribution grid or in the oil field, and those devices, those gateway devices that communicate back to the back office, have inside them the ability to do their own analytics and their own compute. Because if you believe, especially in the utility industry, that the loads are moving from centralized generation to distributed generation, then you also have to think that the compute is also going to also move to the edge. So you can imagine a scenario, and I know this is happening in Mexico. I don't know how long it'll take for it to happen, but there's a lot more renewable energy being installed in the grid. So I'm somewhat familiar with the recent bids that went out and some of the awards that were given. This is generation that's put into the market in a place that generation didn't exist before. And if it's renewable, like a PV, or a utility scale PV unit, you can imagine having, let's say, a dozen of those deployed across the CFE grid. You know, one in Monterey, one in Querétaro, it's all scattered about. One part of the day, it's cloudy in one area, and another part of the day, it's very sunny in another area. As the clouds move and the weather patterns change, real-time decision-making has to occur to maximize the energy produced from these new renewable energy resources. So one would argue that that compute and those analytics that drive some of those decisions have to occur in the field at the point of generation, as opposed to the alternative is send all the data up to the cloud, do the crunching in the cloud, and then send it all back down and make a decision. So we would argue that that latency that's built into that, and it's not much of a latency, but it's enough of latency for it not to be able to react in real time the way we would want it to react, again, as these renewable energy resources get deployed in the field. Another use case and how we're working in this new smart world with the Internet IoT platform is, as I already mentioned, and you guys are aware, as the oil and gas industry changed based on the price changes and the fact that, again, there were fewer people out in the field doing some of the things that they've been doing for years, we've deployed technology, for instance, on oil rigs, oil production rigs, where there are fewer people there monitoring. This allows the oil and gas company to track and monitor wellhead conditions, track and monitor equipment conditions from these IoT devices and edge devices. And if there's enough compute on the rig, in the gateway device, it can actually make decisions real time on the rig without having to, again, deploy field resources to those locations. The last piece of this, and I'll mention it before, is this end-to-end security. Everything we do with all of our clients, that's one of the first places we start, is to ensure that there's a full, well thought out critical infrastructure program thought of, as well as full interoperability between the devices that get installed in the grid. And then finally, all this data, and you can imagine all the amounts of data that come from these new platforms, they all flow up into the data center, and Intel has a great position in that market to help companies through their cloud compute and high-performance compute scenarios to help you take that data and use it for new insights into your operations. Any questions so far before I move on? Okay. I'm going to skip this one. We've already talked a lot about the security piece, and I'm going to just go into, this is the last slide, and kind of think ahead about, you know, where this industry might be going over the next 3 or 4 or 5 years. And I think we've talked about the fact that with the proliferation of the Internet of Things, which is a great buzzword, but the more devices that get out in the field, the more edge compute that occurs. I think you're going to see a lot more real-time data management happening and a lot more real-time decisions happening in the field once these technologies get in place and companies learn how to best take advantage of them. I think in some cases, you're going to start hearing a lot more about, especially in the Intel case, 3D capture and facial recognition. We talked before about the connected experience. Intel's about to launch a new product, a new smart home product that basically the experience as you walk in your house, the gateway itself, or we call it a hub, is sitting on your table. It has the ability to recognize you visually as you walk in the door. It sees who you are, and they can actually talk to you. For instance, let's say you walk in the house, and it says, "Hey, Mike, welcome home. Tomorrow at 4 o'clock, CFE is going to have a critical peak pricing event. How do you want to participate?" You could tell the device to go into energy savings mode, and it would automatically change that settings of all your devices in your house to respond to that. So it's a really cool way for folks to actually interact. And I think about my own mom and dad and their ability to use some of the IoT technologies that exist today. They would never buy a gateway, install it in their house, pair up a bunch of devices, put them on their phone and program them to work the way they wouldn't even start. They wouldn't even think about it. But if you can imagine putting in this facial recognition, voice recognition interaction, that all you have to do is actually talk to it and it'll do the things you need it to do, including setting up your system. I think it opens up a whole new world of folks that especially in the energy world, that would interact with the utility company. And finally, one last thing I will talk about, and I don't know how long it takes for this to occur in terms of forward thinking in Mexico, but in some markets that are like Mexico, that have reformed, that have seen a growth of consumer-owned assets like rooftop PV or controllable loads in their home that are connected, we have seen and are driving an exchange platform that allows that customer to trade their own energy, either that they produce or that they control, back to the market and get paid for it. So you can imagine, I would call it Uber for energy. If you own a device like that, if you own rooftop PV, you own battery storage, you own a connected thermostat that can be turned down, you would then have the ability to trade that energy into the market simply by the market sending you a signal. Could be by your phone, just like Uber does. So Uber, if you're an Uber driver, you take your car, you register it to the Uber platform. It has to pass through a certain test, but once it's on the platform, it's now available for someone to call it and actually borrow it. It's the same true. If you own an asset, you register that device to the platform, and you tell the market that that device or that rooftop PV system is available for the market to share. Wherever you are, if you're at your office and CFE calls you and says, "Hey, I need to take the energy off of your rooftop PV system and put it on the grid, I'll pay you $50 or whatever it is," you just simply hit one button, you accept their call, and then the system goes in and routes the energy from your home to the grid. The next day you go to your app, you look at it, and you've received a credit from CFE or from the market, just like Uber. So I think those are one of the areas. You see a proliferation of devices, you see a proliferation of new data streams, and you also see the growth of renewable energy resources hitting the edge of the grid. I think that's the logical next step. So hopefully we'll see something like that here in Mexico as well, where we get consumers participating in the market. And that actually concludes my comments today. I really appreciate you guys inviting me in to visit with you. I'm going to be around for a while, so if you have any questions, but before I get off the stage, if there's any questions anybody has about what Intel's doing in this space, how we're working with Cisco, or even any open questions you have about what might be occurring in other markets that you'd be interested in hearing about, I'm happy to field those now. Okay? Well, thank you very much for your time.